Hello everyone, I am Tarun Gupta from University of Florida. I am a master's student in the computer science department, and today I'll be talking about filtering spam emails using pattern recognition techniques. So let's start with a basic introduction. So what is an email? So electronic email is a computer-based mail and messaging system. In today's world, emails are a major way of communicating over the internet. So nobody in today's world uses postal, emails. Nobody goes to post offices. Everybody uses email. They are a mode of genuine communication, but everybody knows that it can also be used for advertisement, threats, and other forms of cybercrime. So, spam is a type of cybercrime associated with emails. So, what is spam and what are the problems faced due to it? So, email spam, also known as electronic spam, is defined as unwanted messages in large quantities without the consent of the receiver with the purpose of personal benefit and causing loss to the receiver. Spam causes various problems such as traffic overload, reduced productivity of network, unnecessary wastage of space, and irritation to the receiver. So, how does it cause traffic overload? Consider a sender sending thousands of emails to a particular user. So, because of this, the network will get overloaded, and this will in turn lead to reduced productivity of network because the genuine emails will not be able to go through. Instead, it will have to wait for all the spam emails to go through. This will obviously cause unnecessary wastage of space because your email address will be full and your inbox will have a lot of waste emails, and this will obviously cause irritation to the receiver. So what are the different types of spam? There are adverts and there is phishing. So advertisements are the emails which are used for advertising some products. So according to Wikipedia, the most common product advertised are related to pharmacy. Why pharmacy? Because a lot of people get sick and there are a lot of pharmaceutical companies out there which are creating a lot of different medicines, and therefore it is a very profitable business, and as pharmaceuticals are costly also, so everybody wants to get their product out there. And phishing is a medium of cheating users into tricking them into revealing their private information such as credit card or bank details by forging mails from various organizations. So for example, you will receive a mail which will say that your bank needs to verify your information, so please enter. There'll be a link. When you click on the link, you will be redirected to a website. So that website will be created exactly same as that of your bank website, and it will ask for your credit card details or your login details, and those details will actually be sent to the sender, so they'll be having access to your account and they'll cheat you. So what is the purpose behind spam filtering? In the last decade, spam email has caused a lot of problems, and in spite of all the work done in this field, spammers still find new ways to send emails which are not caught by the spam filters. For example, earlier spam based filtering techniques were based on text. For example, some words were considered as present in the spam emails, so therefore if a lot of those words were found in an email, it was considered as a spam email. But spammers have now become very intelligent and they are sending images instead of text, so that it is very hard to find and process the images. Also, there are some spam emails which are blank. This type of emails are basically used for determining whether email address is valid or not, and therefore if it is valid, then it will be subjected to further spamming. So therefore it is a very important that we know what the issue is and we consider it seriously, and we develop the filtering techniques according to the new spams. So this issue should be taken seriously. So what are the terms used in the project? So spam email, these are unsolicited email with purpose of advertisement and phishing. Non-spam email, these are regular or genuine email. And spam non-spam ratio, This is the number of spam to non-spam emails. Accuracy, this is the percentage of emails correctly identified as either spam or non-spam. And error rate, these are the percentage of emails incorrectly identified. False positives, these are genuine emails which are recognized as spam emails, and running time is the time required for the algorithm to run. So we will be using the following algorithms for our spam detection techniques. So we'll be using naive Bayes classifier, k nearest neighbors, and support vector machines. We'll implement these and check whether which of them is the fastest and how much time each of them take. So let's start with naive Bayes classifier. So naive Bayes classifier is derived upon Bayesian classification model by Thomas Bayes. So it is based on probabilistic and statistical learning. It assumes that the value of a particular feature is independent of the value of any other feature. So for example, if a car has certain features such as AC, alloy wheels, hoods, decals, so all of these features will be independent of all other features. So this is basically a conditional probability model. So basically, if out of 4, 3 features are present in an object and we have set the threshold as 75%, then we would obviously identify that object as a car. So advantages of naive Bayes classifier is that it requires small training data set to estimate parameters for classification. Let's see the formulation for naive Bayes classification. So according to Bayes classifier, probability that an email containing given word is spam is given by the formula which you can see in the video. So here PS over W is the probability of email being a spam known that a particular word W is in it. PW over S is the probability of word W existing in spam emails. P of S is probability that email is spam. Similarly, P of H is probability that email is not spam. PW over H is the probability of word W existing in non-spam emails. So using this formula, we can determine the probability of the email being a spam, knowing that a particular word is in it. So let's see how does this work. What is the process of this classifier? So different words have different probabilities of occurring in spam and non-spam emails. The filter doesn't know the probabilities of these words in advance and hence has to be trained in order to classify them. And we can do this through training data set, which will help to the filter to calculate the probability of words. And we have already seen the formula for calculating the probability of words in this slide. So using this formula, we can determine the probability of the email being a spam, and so in the first step we are calculating PW over S, which is the probability of word existing in spam emails. So these word probabilities will in turn help to compute the probability of email belonging to spam or not spam. So how it is done? So basically, if an email contains like 100 words, so we'll count the total probability of all the words for which we have data available, and then we'll check whether the total crosses the threshold which we have set for the filter to be classified as spam, which is usually set higher than 80%. So if, for example, out of 100 words we get around 50 words which we know belong to a spam, and those words have a very high probability of being in a spam email, and that crosses, for example, more than 80%, then we know that that email is a spam. So the naive Bayes filter accuracy is usually around 80 to 85%, and that is pretty good, and it is a linear algorithm, so its complexity is also very good. So usually the time taken by the naive Bayes classifier is less. So let's see the next algorithm, which is the k nearest neighbors. So the k nearest neighbors algorithm, unlike BAS, is a non-parametric method used for classification, and it is an instance-based classification where computation is deferred until classification. So let's see how k nearest neighbor works. So as you can see in the diagram, we know that the red dots belong to one category, and we know that the blue dots belong to one category, and we have to classify the green category either as the red category or the blue category. So as the name suggests, k nearest neighbors, we have to find the k nearest neighbors, and whichever neighbor has the majority, the green will be classified in that class. So what is the process? Given n training data points, this algorithm identifies k nearest neighbors and classifies the testing data according to the majority class, as I said. So we separate the data as training data and testing data, and hence no pre-processing is required. In this, for each training data, that is email, we check the category of its neighbors, and based on the majority we classify the email as spam or non-spam. So this is fairly easy to understand, but let's see what are the issues and how does this work. So an important part of this algorithm is choosing an appropriate k value. So in our algorithm, basically we are dealing with a two-class problem, right? That an email is a spam or an email is not a spam. So that means we have two classes. We have spam and non-spam. So therefore we have to take k as odd, which will allow us to categorize the class easily and not result in a draw, right? Because if we are taking k as 3, then we'll have 3 of its neighbors, and obviously 2 will belong to one class and another will belong to another class, and hence one of them will have a majority, and we'll able to easily categorize the testing data. If we have an even number k, then it may happen that for k is equal to 8, we have 4 points which belong to one class and 4 which belong to another class, and then that will result in a draw, and hence we'll not be able to categorize the point. In general, k must not be multiple of the number of classes, because that can lead to a draw. So let's move on to our next algorithm, which is support vector machines. So support vector machines are supervised learning models which analyze data for classification. So given a set of training data, each new data is classified as belonging to either of the categories, so making it a non-probabilistic algorithm. So it's similar to k nearest neighbors. It's not based on probabilistic algorithm such as the naive Bayes, but it's much better than k nearest neighbors, and it's pretty fast. So let's see the process. So support vector machine creates a hyperplane or a separator such that there is maximum margin for classes. So as we can see in this diagram, here there are two type of classes. One is the circle and one is the square. So these are the different type of hyperplanes which we can create such that we have maximum amount of margin from both the points. So we have to select from these are all the possible planes which we can create, but we have to choose the optimal plane which has the maximum margin of points from both. So there may be various such separators because we are dealing with only two classes. So it's usually very easier to determine a hyperplane, and there are more than one. In case of more than one classes, it's difficult to even get a single hyperplane, so there is no case of choosing multiple hyperplanes. So as I said that generally, ideally SVM should be able to separate the classes completely, but we know that that is not the case because our case is generally not that easy. So in case of overlapping, what do we do? So as you can see in the figure, we see that we can't obviously separate both red and blue exactly on the same side because one of the red is in the blue part. So what do we do here? So we try to find a hyperplane that maximizes the margin and minimizes the misclassification. So as you can see, we have chosen a blue line, which is a hyperplane, optimal hyperplane. Why it is an optimal hyperplane? Because firstly, it is maximizing the distance from both the blue region and the red region, and also it is minimizing the misclassification. There is only one point which lies on the other side and its distance is minimum. We cannot do better than this. If we try to minimize the distance, then we'll minimize the margin, and therefore this is the best scenario which we can do. So there is another method known as kernel trick. So as I showed in the previous figure, this case is also very tough to determine because a lot of times it happens that there are not a single point, but there are a lot of points which are on other side, and the two of the classes are totally mixed up, and it's very difficult to find a plane which will separate these both classes. So in such a scenario, we use the kernel trick. So what is kernel trick? This is a method which we use when the training data cannot be separated in the same dimension, and hence we have to map to a higher dimension in order to separate them. So as you can see in this figure, we can obviously see that we cannot draw a hyperplane to separate the red and the blue part. So what we have done is, instead of a 2D plane, we have mapped it to a 3D plane, and here you can see we are easily able to find a hyperplane which separates both the red and the blue parts. So this is known as a feature space, and now we can easily solve our problem. Here are the results which show the running time and accuracy for all the three algorithms. But let us first see the implementation of these algorithms, and let us first run these algorithms so that we get a clear idea. So for running these three algorithms, we have used the SpamDays documentation, which we have taken from the UCI machine learning library. So it contains around 5,000 items, around which there are 3,500 items are spam and around 1,500 items are non-spam. So here is our knife Bayes algorithm. So we are taking data from the spambayes.data.csv. So using the function load CSV, we load all the data in our data set, and then using split data set, we split this data into the training set and the test set. Then we summarize this training set by class, and using this summaries, we predict whether that word belongs to a spam email or a non-spam email. We already discussed that in our presentation, that we calculate all the probabilities of the words, whether that belong in spam or non-spam, and then by counting all these probabilities, we determine whether this is a spam or not. So that we do in accuracy. So how do we get an accuracy? We get accuracy, we have already calculated the probability of all the words. So in accuracy, we just check whether whatever we tested is correct, and if it is correct, then that accounts for the accuracy. So usually when we run this knife Bayes algorithm, we get around 80%. So as you can see here, we get around 80% accuracy, and time taken is also very less. So let us try to run this one more time and let's see. So here you can see its accuracy is 81% and time taken is a little bit high. Let's try it out again. So accuracy is increasing, 82%, 80%. So it's around basically 81 to 82%, and time taken is around 1.5 to 2.5 seconds. So here is our KNN algorithm, which is the k nearest neighbor. So here again we use the spam based database, and we split our data into training set and test set. Then here we are using an appropriate value of k, which is k equal to 3, and we are getting all the neighbors of the test set. So here is our test set for which we want to check whether this test set belongs in spam or non-spam. So using the get neighbors algorithm, we are able to do so. Here is the get neighbors algorithm. So we calculate the Euclidean distances from the test set towards all the training set in k distance around it. After that, we calculate the result from all the neighbors, and using that result we predict. For example, the result is 2 of its neighbors are non-spam and 1 is spam. So in predictions, we predict whether this test set is spam or not spam, and then we calculate accuracy similar to that in naive Bayes. So let's see what results does this algorithm give. So we have already run KNN here. So as you can see here, training set consists of around 3000 points, testing set consists of around 1500 points, and accuracy is 79%, and running time is actually very large, around 5 minutes, so we will not be running that again. So here you can see that accuracy is almost similar to naive Bayes. It is a low, but the major issue is time. As you can see, we are getting a very huge time, so this is not a good algorithm, and therefore it's not very good to use. And we'll see that this value also tends to increase if we change the k value, and the accuracy also decreases. We'll see that later in the presentation. Next, let's go to our third algorithm, which is support vector machines. So here is our third algorithm, SVM. So here we have selected a segregation ratio, and we are using the spam based data. So what we do is we divide our training set and the testing set into two x and y coordinates by using segregation, and then by using kernel. Here we are using a linear kernel. So by using a linear kernel, we calculate the accuracy. So let's see what running time we get for SVM. So here you can see that accuracy is very good, around 93%, but running time is still around 5 seconds, so it is still slower than naive Bayes. And now let us check the results. Now here let's compare the results. So naive Bayes takes around 1.2 seconds, accuracy is around 84. This is the average of around 10 iterations. So k nearest neighbors take around 200 seconds, accuracy 80%, and SVM takes around 4.5 seconds with accuracy around 90%. So here we can easily see that the accuracy of SVM is highest, but naive Bayes is also pretty close, and it's considering its running time is very much less than both of these. Naive Bayes can be a very good algorithm. So let's see the effect of k nearest k in k nearest neighbors. So accuracy and running time. So as you can see here, accuracy of the algorithm greatly reduces if we increase the k value, and here time taken also increases, not that much drastically, but as we have already seen that initially it's already much larger, so it's initially it is bad, so it gets more worse when k goes on increasing. So what conclusion do we draw from these results? So as we have seen, we have implemented all the algorithms and we have analyzed our results. We can come to a conclusion that k nearest neighbor is the worst in terms of accuracy and running time, so we can easily discard this algorithm. Next, the SVM and naive Bayes are almost similar in accuracy. SVM is a little better, but when we calculate the complexity of both these algorithms, SVM has a quadratic complexity whereas naive Bayes has a linear complexity. Therefore, as we are using a small set, we can't see much difference in time. Still, there is a difference of about 4 to 5 seconds, but as the data set goes on increasing, SVM performs very badly, and there is a lot of difference between both of them because of its high complexity. Hence, among all the algorithms, naive Bayes is the best algorithm because here we have a proper trade-off between accuracy and running time, and hence it can be easily be implemented in email spam filtering techniques. Alright, so thank you. This is it. Have a nice day.